I'm a lot more accurate measuring 4 sides with a tape measure than I am expecting my room is perfectly square. So if you wanted to write it 73, that would be great with me, but I'm putting 73.1. Whoops, except I got the wrong answer. This is 20.5, so 72. Didn't think it would be 0.1. Where did that one come from? Okay, you're supposed to catch my mistakes. Okay, there we go, we got it.
Kind of wanted to question that answer, but I wasn't too sure.
You be sure. I'm thinking also about like what color I want to use next and where to write it on the page and all these things. That distracts my brain. Okay, we're almost done. There was one more word problem on that. 3P plants measure 6.5, 5.25, and 4 inches tall. Find the mean, the average height. We haven't talked about averages yet. That's later in the term, but you've probably seen them earlier in your lives. How do we find the average? Who remembers from something else before?
I'm not sure.
So add them up. And then divide by how many?
Would it be 3?
So the how many is 3. When I add them up, I'm going to change these things to decimals again because that's just easier for my calculator. So 6.5, I would make 6.5. 5.25, I would make 5.25. And 4 is just 4. So 6.5, 5.25, and 4. Oops, that's not a point. There we go. So 15.75. And then if I take my answer and divide it by 3, 5.25. So we'll do averages more, but there we go. Why would they put this problem on a worksheet about order of operations? Because I could write it as 6.5 plus 5.25 plus 4 as a first step, using parentheses to say do this first. And then divide by 3 afterwards. So I could write this whole thing as one line instead of doing part of it up at the top and part of it down at the bottom. So that's why they like putting this on an order of operations. But it is a little out of place. We haven't done averages yet. Okay, that was the first 2 worksheets. What are you in the mood for? Do you want to do more worksheets? Do you want to talk about new mad science topics? You want to look at the mad science overview and see which of these we want to work on more?
I'm fine with whatever, but I would like to do more worksheets.
Worksheets. Okay. Any other good votes?
I probably
I'd
would
like to do the worksheets.
Worksheets. Okay. Let's do.
worksheets work.
So the next worksheet is a multi-part thing. And one of my neighbors is planning a major yard renovation. She wants to reseed her entire lawn. And looking at this picture, she is also going to reseed her driveway. We're just going to pretend that happens and not notice that whoever designed this problem is having her reseed her driveway. And she's going to fence the two sides and back of her yard. So not this street side on the right edge. So here's the overview, and there's the measurements. So for now, I'll make it big, but we might shrink it so we actually have room to write something. Now, this is a good part to stop for just a moment and do an interruption. When we talked about the mad science stuff before, then remember this thing that we did to make sure we understood our area formulas?
Yeah.
So this is one style of the kind of problem that might show up on a test, where I have a shape, there's no numbers on it. Nobody put a number 4 here or a number 3 there. I just had to count the boxes and label it myself. A second way that it could happen is what we have in this worksheet. Somebody draws the picture for you or describes the house very carefully and puts all the numbers in. So that works too. The third thing that could happen is somebody draws a shape and then you have to measure it with a ruler. I don't think it is true on the GED, whether you take it in person or with the remote proctoring, that they just give you a ruler and you have to measure things. So it will always be that the picture has numbers on it, or that there's boxes and you count boxes like we did on that other one. So Ruthie and I had a nice little study session yesterday. So if you missed it, that was one thing we talked about. Okay, back to the handout. What are we supposed to do with this? For the lawn, she has selected grass seed, and we're supposed to estimate with $12, and the bag covers 1,200 square feet of area. So let's start with that. Is the picture reasonable size after I shrunk it? Can you read all the numbers there?
Yeah.
So your job first is to sort of mentally picture, how do I get the light green area I obviously need to find the big rectangle and subtract the house, but there's more than one way to do that kind of thing. So think about what you would do, and then we'll share our ideas in just a moment. Okay, so what I've been drawing while I asked you to think was we don't actually know how to find the white area in one step. We know how to think about rectangles for area, or triangles, or parallelograms, or trapezoids. So some people will say this house here has a top part, as on the map, and a bottom part. So I am going to break my house, oops, into 2 bits. And I will find the top, and I will find the bottom, and I will add them together, and then I will take that away from the whole green amount. Other people will say, I agree, I can't find this white Tetris shape all in one go, so I'm going to take the main part of the house and find it, and I will take this little kind of rectangle close to the front of the street and find that and add those together. So these people would break it this way and say that they have a back there and a front there, combine those, and then take all of that away. Other people will say, I'm going to just make this house a rectangle and take away the whole rectangle. And that means I took away this little bit in the bottom corner that I shouldn't have. So when I'm done, I have to add it back in to make it right. So who picked the top plan? That was what you thought about in your head.
I did.
Who picked the middle one? Who picked the bottom one? No one. So those of you who are quiet, did you have a different way you did it, or just hadn't finished things up?
I worked on the top one. Sorry about that.
I'm not surprised. I think most people will pick the top one. Almost everyone's brains likes chopping things up kind of top and bottom more than left and right. I don't know why, because they work equally well. So that's what we're going to do. So back to this, we have some red coloring in, and we have some blue coloring in, and we are going to do a green rectangle. Oops, make that look. And then we're going to subtract from that the red top. And then we're going to subtract from that the blue bottom. So pardon my artwork, but everyone okay with my plan?
Yeah.
For
Yeah.
all of these, the area of a rectangle is length times width. So all I have to do is stare at the picture until I find the length and width for each one. And since everything is nicely color-coded, I will keep using my colors. So for green, I stare at it and I say 80 and 140. And then I take away and I stare at it. Okay, where's my numbers? Which 2 numbers do I care about for the red part?
30 and 50.
30 here, up and down, and 50 there. And then we're going to take away. And again, I need to stare at this. So 30 here and 40 here. Everyone okay with finding the two numbers that fit each rectangle?
Yeah.
We didn't use everything, right? This 20 we didn't use. This 70 we didn't use. If you had different plans, then you might want the 70 or the 20. But it's okay. We did our plan. We found the numbers we wanted. I could put all of this in my calculator. Calculators handle this just fine. Do I need to put parentheses around my stuff?
I don't think so.
If it helps your eyes, you certainly can. Those are the three things we're doing first. But you are correct. We don't need to. When we're thinking about terms, this is already a term. This is already a term. This is already a term. If you're thinking about PEMDAS, we're going to do our multiplying before we do our subtracting. So the order of operations is fine, even if we don't write the parentheses. If it makes your eyes appreciate the problem more, go ahead and put them in. Anyway, 80 times 140 is 11,200. Thirty times 50 will be 3 times 5 is 15 with 2 zeros. 3 times 4 is 12 with 2 zeros. Then I do my subtraction and I get 8,500. Everyone okay with my answer so far?
Yeah.
Yeah.
Now we need to kind of go back over to this side. Each bag was 1,200 of square feet of this stuff. So I'm going to highlight that. And then writing in yellow, what's my next step? How many bags do I need? What kind of arithmetic will I do?
I got 7,600 and I have no idea what I did wrong.
Let's check. 80 times 140. Minus 30 times 50. Could have been us doing a typo. And 30 times 40. No, 8,500.
I'm unsure. I should have written it down instead of just using my calculator.
Yeah, if we were in a real room together, I could walk over to where you were sitting and look at what you punched in the calculator. But I'm sorry.
Yeah. I might have just like put a number in that I thought I did. I am not sure.
Okay, well, back to the yellow part. What do I do with this 1,200? How many bags do I need?
Would you divide it by the 8,500?
Yes, remember we talked about division a long time ago, very first class. And if you think about making piles of a fixed size, that's what we're doing. How many piles of 1,200 do we get out of 8,500? So divided by 1,200 and I get 7.08 something. So now I have to decide, am I rounding up or down? If I really wanted enough seed to cover all of that green area, I would have to round up. Otherwise, I would be a little bit short. So if you wanted to put the answer of 8 bags, then you can justify that. I think I'm going to round down. Since we mentioned at the beginning, there's a driveway here, and whoever designed this problem forgot about it when they drew their picture. So since I really don't need to buy enough grass seed for the driveway, I'm just going to pretend that that's not there. So about 7 bags. Okay, I'm out of colors, so I'm just going to use green for money. What do I do with that $12?
Multiply it by 7.
Yeah. That 8 looks kind of funny. So, ta-da, now we know what she spends on grass seed. That was a much nicer, more realistic, pleasant problem than the recipe one we started with. We got to talk much more about interesting things and not just smashing fractions together. If you care about recipes, then we can eventually talk about, in the health decisions application section, food preparation and recipe scaling. And then we'll actually go into using some tools we'll get soon with proportions, and we'll talk about trimming produce, because there's this thing called yield percent, right? When you buy an avocado, there's a pit in the middle. You don't get to use 100% of the avocado in your recipe, and so on. So we can do recipes the right way without fussing about teaspoons of baking soda. But anyway, this was good. Okay, we're not done. Questions about the grass part of this?
I'm good.
Okay. So for the fencing, she's selected some nice cedar pre-made panels that are 8 feet long and cost $7. And I need my picture again. And remember that she wants to make a fence that goes on this side, and this side, and this side, but not the front by the street. Not there. So how many feet is that total?
$360. Is that right?
Is that right? How did you get it?
I did 140 twice and then added the 80 feet.
Yeah. So you could certainly do that. 140. Whoops, that's not my highlight. 140 and 140 and 80 and get 360. 140. I'm not sure that's the right thing to do, though. Let me look at this again. So she's buying these panels that look pretty fancy and nice. And do you see how there's like trim that goes all around them? I'm not sure that I can cut them in half well. I think we need to make an executive decision. Is it okay if we just take our skill saw and chop this thing in half?
Probably not.
Since each of them is 8 feet, then 10 of them will fit fine here. 8 times 10 is 80. But if I do 140 divided by 8, then I'm going to get 17 and a half of them here. So what do I do with the extra half? Can I use it again up on the top, or is it just going to fall apart? Let's pretend we can use it again, be more positive. So that's okay. We can just use all 360 feet. We don't need to buy one extra panel because we're chopping them up. So then I will just say 360 divided by 8. $45 of these panels. And then as my last step, what do I need to do?
Multiply by 7.
Not 7, unfortunately. She'd be really happy if they only cost $7.
I meant 57, sorry.
57, yes. So times 57 is 2,565. And if you wanted to add another $57, because you're going to say that if you cut it in half, something goes wrong, then you could argue that too. I am going to pretend she can save money. Okay. Well, hopefully that was somewhat entertaining. Should we go ahead and finish up to the 4th of the handouts?
Yes.
Yes,
Okay.
please.
That works.
Do people, since it's 7:40, want to take a 5 or 10-minute break before we do that?
Yes, please.
Yes, please. Okay. Should I see you in 5 minutes or 10?
Either way is fine with me.
Let's just do 5 minutes, and then if we want, we could just end class a few minutes later towards the end. So 7:39-ish by my clock. See you in 5 minutes. I'll stop the recording. Resume. Welcome back from the break. The fourth handout is perimeter and area. Let's start by just labeling our shapes. So tell me for each of these: square, rectangle, parallelogram, triangle, or trapezoid. So what's our first one?
Parallelogram.
Okay, the second one.
Same thing.
Same thing. I'm gonna be lazy and just copy and paste. Okay, third one.
Trapezoid.
Trapezoid. Fourth one.
Same thing.
Same thing. And the last one isn't really any of this. We have to break it apart. So how would you break this apart into different smaller shapes that we can add up?
I believe into a trapezoid and a rectangle.
If you make one cut, oops, which I'm not very good at drawing, then yes, the top is a trapezoid and the bottom is rectangle. Some people will want to do more than that. That's the simplest way to do it. But if you wanted to, you could make extra cuts. If you don't like trapezoids, remember, you can always chop them up into smaller things. So that's sort of step one. Do we know which shape it is? Because then we know what formula to pick. Now, step two is a lot of these formulas have a base. And remember, the diagonal things don't count. None of the formulas have diagonal edges. So let's make sure that we cross out all the distracting diagonals and that we have a measurement of base and height. So for this first shape, what numbers should I cross out?
The 10?
10, they're diagonal. I don't care about them. Doesn't matter which 14 I care about.
Just the base?
Yeah, I need the 14, that's the base. This one I really don't even need to have. How about this parallelogram?
Would it be the 8s?
Yeah, and like everything is all funky. What's the big difference between these two?
The height's going the other way.
Yeah, so let's fix that. The height should look like a height, right? So if I do that, then I can see that my height is 7. What number is going to be the base now?
6.
6. So then these 3 I don't care about. Everyone happy with that?
Yeah.
So
Yep.
if they're trying to measure a height, you have to cut through the middle of these parallelograms because the diagonals don't count. Then if they're cutting through the wrong way, then just rotate it. Okay, trapezoid. Let me get my cheat sheet again. For the trapezoid, remember that we have one of these, which I called the top, and then another one that I called the bottom. They call them B1 and B2 on the GED sheet. But just pay attention that that's what's going on there. So we need the top, we need the bottom, we need the height. We'll also put a half in there. But we can get rid of this 9 and this 8. Okay, how about my bottom trapezoid?
You would get rid of the 5s on
Yeah.
the side.
I'm going to start by rotating it because I want my height to be up and down. So that's 4, that's 5, that's 3, and then these I don't need. I will actually need all the stuff I'm crossing out later when I'm finding the perimeter. Right, then I have to add up all the sides. So I'm going to use my eraser tool. I'm like, aha, there it is. But for now, when we're finding the area, since it asks us to do that first, then we're pretending we don't see that. Okay, now for the trapezoid, let's draw that with red. I need the base and the height and the top, or bottom, the top, and the height. So what's the height going to be for this trapezoid?
Would it be 4?
It is. How did you get that?
I took the 15 and subtracted it from 11.
Yeah, the 11 gets me that high. So this part must be 4. So I will put 15 minus 11 equals 4 over there. Okay, and what's the base of my trapezoid?
16.
16. And then for the rectangle, length times width is right here, 11 and 16. So now I can cross out this 15. I've used it, I don't need it anymore. Everyone okay with my preparation steps?
Yeah.
So I would not normally do preparation for 5 different problems all at once, but just for lecturing to do some compare and contrast, I wanted to go through more than one at a time. Okay. If I was actually taking the test, I would just do this problem first and get it all done, and then I would do this one first and get it all done, and so on. Okay, so we've got rid of our distractions. We've rotated things if we need to. We've labeled what shape we're going. So we are set. Let's just plug things in and go. So for a parallelogram, it's base times height. So 14 times 8, whatever that is, because it's late and my brain is tired, is 112. And none of these were labeled with feet or inches or anything, were they? So
No.
I'm just going to say area. Now we have to find the perimeter for it. Should we do all the perimeters at the end, or should we do each one as we go?
As we go.
As we go. Okay, so then I have to uncover my hidden numbers. And I want to add them up. I'm going to highlight them. So 10 plus 14 plus 10 plus 14 is going to be equal. 4 tens is 40, and another 4 and 4 makes 8. So 48 perimeter. And this feels awkward to me. I wish they gave me feet or inches or something to label it, but they didn't. Ready for the next one? Somebody call out what to do.
Base times height, which would be 7 and 6. Then I uncover my hidden numbers. I'm going to highlight the perimeter. So 8 plus 6 plus 8 plus 6. So 8 and 6 is 14. Again, there's another 14, so 28 for the perimeter. Is my math good? Am I making mistakes? I
You're
think so.
good.
Good. Okay. On to the trapezoids. So we want 1/2 times height times top plus bottom. So 0.5. One other thing we talked about yesterday when Ruthie and I had a little study session was the 1/2 you can always make 0.5, whether it's triangle or trapezoid. It's easier to put into your calculator as a decimal. Okay, height right there, 7. And top plus bottom, 6 and 10 is 16. That's going to be half of this and this. When I'm multiplying 3 things, it doesn't matter what order. So I can, in my head, do half of 16 as 8, and then 7 times 8 is 56. Then 6, 8, 10, 9.
So what's that going to be? 19, 25, 33. Okay, someone other than Sequoia. What do I do for the next one? It's still a trapezoid. The formula is going to be the same.
So you'll do 0.5 times 4 times 8.
Yep. If you wanted to write out 3 plus 5, you could. To me, it's less confusing to just make it 8.
Makes
So
more
put
sense
that
like
in-
that.
Put that in your calculator. Half of 4 is 2. 2 times 8. So I'm going to get 16 for the area. This is a little awkward being rotated, but I can read numbers sideways. I'm a parent. I'm good at reading things upside down. So that,
18.
that, and that. So 5, 10, 15, 16, 17, 18. 3 5s and an 8. Perimeter. Okay. We're on a roll. Okay, so the trapezoid part. So same formula, 0.5 times the height times the 8 plus 16, so 24. So half of 4 is 2, 2 24s is 48. But we're not done because we have to add it to the rectangle. Let's give the rectangle a color. So that's just length times width. 11 times 16. 176. What's my last step?
Add them together.
Yeah. And the total is, so plus 48, answer plus 48, 224. Okay, for the perimeter of this one, I am a little confused by this. Let me double check that. So they don't give us these little diagonal bits. And with what you have been taught already, I don't think you know how to find those. You can kind of imagine if we took this 8 line and grabbed it and dragged it up, that it would stretch out these diagonal lines, right? And if we took that green line and instead moved it sideways, then it would make one of these bigger and one of them smaller as you screwed it back and forth. And we don't have any measurements in this diagram that tells us it's right in the middle or anything like that. So I think with the math you know so far, we can't do the perimeter on this. So we'll just skip that. That's okay. as a heads up of what's coming up in the future, once we do justice, the things with equal signs, then we'll do a lot more of these area puzzles. So we'll have all sorts of interesting things there, but that's as puzzly as we'll get right. Okay, we have done it. We've conquered all 4 of these handouts in our table, our syllabus. Then we have done all 4.
Woohoo!
Ooh, good for us. Should I tuck them in the week 5 foldouts, or do you want them to keep floating in the middle of things?
I like him in the middle.
In the middle, okay. I might put them after week 5 because 2 of them you couldn't have done much unless we got geometry. But, yeah. There we go. Okay, so there we go. We've done that. I'm tempted to do a little bit more with circles, but maybe not. Should we just stop a few minutes early? Do you want to look at the 10 exercises for measurement? Maybe do one of these.
Can we do one of those?
Sure. I'm going to change the numbers on you, so I'm not doing your homework for you. I guess not as many as you want. We have 17, 18, 19. We have 3 pages left in the Jamboard, so maybe we should do 3 or less.
That works.
Which one do you want to start with?
Can we do number 5?
5, yes. Pardon me as I recycle things to make it move nicely. And I will put that we are doing mad science measurement homework. So I made this problem up years ago. I'm guessing Sculpey no longer costs the same. But at the time, you could go to Amazon.com for the US, or you could go to the Amazon.co.uk and see what it cost in England. And of course, in England, they use pounds and grams, not dollars and ounces. But if you had Amazon Prime and shipping was free, then maybe you would want to buy one or the other because it's cheaper. So let's see which it is. So Amazon.com. And $7.29 for 8 ounces. And I'm going to write that not as for, but per 8 ounces. Because per I like. What does per turn into?
Division.
Division. And whatever that is, 729 divide, oops, 29. So 91 cents per ounce. Okay, so that was the easy part. Now I need to compare that with the one that starts out as pounds and grams. So this is what we did in mad science called unit analysis. Remember this multiplying fractions stuff?
Yeah.
I will take this, and just as a reminder for what the process is, I'm going to put it on the page, but I'm going to make it way too small to read because we need our space. But this is just sort of your little visual reminder. Oh yeah, that's what we're doing. Go look that up if I needed to. So the first step was to write things out as fractions. So 2.2 pounds for 57 grams. Now I want to add other fractions, other rates. One of them is going to help me get from ounces to grams, or grams to ounces. And the other is going to get between dollars and pounds. And it doesn't matter which one I do first. Anyone care?
No.
No.
So I'll do the blue one just because it's on the left. So am I going to put my grams on the top or the bottom? Am I going to put my ounces on the top or the bottom?
Grams on the top.
Grams has to be on the top. And I know that because I want them to cancel. And they can't cancel unless one is on the top and the other's on the bottom. So grams and ounces, and 1 ounce is 28.35 grams. Then, as another fraction, I have pounds and I have dollars. Which is top, which is bottom?
Pounds on the
Pounds on the bottom, so that the pounds will cancel, and that means dollars has to be on the top. And at the time, 1 pound was $1.31. So I've set everything up. And lo and behold, I have dollars per ounce, which is what I want. Now I multiply across the top, 2.2 times 28.35 times 1.31. 2.2 times 28.35 times 1.31. And I get 81.70. And I can keep all of my decimal points. It doesn't really matter because I'm about to do top divided by bottom anyway. And that's dollars. And in the bottom, 57 times 1 times 1 is going to be 57. The last step of unit analysis is top divided by bottom. Oh, I forgot to change the numbers before we started. I'm doing your homework for you. Oh, well. So all of that answer divided by 57, and I get $1.43. Not even close. Everyone who lives in London should go to Amazon.com to buy their Sculpey if they have free shipping. Okay, 10 exercises. Should we do another?
Sure.
Which one?
Number 4.
Or, oh, okay.
Hey, I have to go do something, guys.
Okay.
You all have a wonderful night.
Thank you. Have a good weekend. Anyone want a study session before Tuesday before Joel disappears?
What's that? You said study session on Tuesday?
Before Tuesday's class. Anyone
Before
need
Tuesday.
together, or are you feeling on top of things now?
I'm feeling pretty good.
Okay.
Me
Have a good weekend.
Yeah, you too. Have a good night, everyone.
Good night.
A football field with the end zones is 360 feet by 160 feet. So what's our perimeter going to be?
360 plus 160 plus 360 plus 160.
Which is what? Do you have a calculator to do that?
I got 1040.
Okay. 6 times 4 is 24, so having a 4 there makes sense to me. Now that's not one, or that's not what we did. That's one lap. But we did 3 laps. So what do we have to do?
Multiply it by 3.
Yeah. So we would get 1040.
3120.
31. Now we want percent of a mile. I'm gonna actually start a new slide. So we are wanting it to make a fraction. We haven't done a lot like this already, but part divided by whole. And we had 3,120 feet. How many feet were in a mile? Anyone remember?
I don't.
5,280.
Yeah, so you could always look it up if you don't know it. Does the GED tell you that kind of thing? No, I have no idea if you're supposed to memorize conversion rates or not for the GED. I should ask about that. So there we go. Fraction makes division, right? Top divided by bottom. And I get 0.59, more or less. I'm rounding. So that's a nice number, but it's not what they asked for. What's my last step?
What was the question again?
What percent of a mile?
Oh, sorry.
Am I going into percent or out of percent?
You're going into percent, ain't you?
So scoot twice to the right. And I get 59%. Ta-da. And I realized I forgot to change it, so I just did your homework. Oh, well.
Oh, thank you.
Secret benefit from a late at night class is I forget to do things. Okay, I'm going to stop recording, check in once more.